Good day, dear ladies and gentlemen. My name is Konstantin Koshmak, and I'm working with Professor Luca Pasquale. And today I want to present my first year research activity, which was connected to lanthanum fluoride-based ionic conductors. First of all, a few words about solid electrolytes. Now it is quite big. It's object of quite big interest in the research sphere because of its widespread using in fuel cells, batteries, and also there is sensors which based on solid electrolytes, which have got quite big amount of positive sides. First of all, it's a small size, low cost, possibility of measuring directly in working volume. For example, in gaseous or in liquid. Also, it's possible to create an array of the sensors which can be sensitive to different gaseous mixtures, which is also quite a good side. And high response, high sensitivity and selectivity, and down here you can see two sensors. First of one works with optic, and the second one is solid state, and you can see quite a big difference between them. My activity is principally related to the materials, the basis of the device, and not to the fabrication of the complete working device. Actually, nowadays there is quite a big amount of work, but still there is a lack of knowledge about microscopic mechanisms that determine the ion conduction properties. Because of crystal structure defects, grain boundaries, chemical composition, and interfaces between different materials, all these parameters are interacting with ionic conduction, and to understand it, or for better understanding, the ionic fluorides is a good prototype system to research and study these objects. Our samples for study was prepared in the vacuum chamber, which you can see on the right side of the slide. Here is a scheme where in the fusion cells there is a material which operates on the top of the substrate, on the surface of the substrate, which can be heated, and crystal structure is controlled with reflected high energy electron diffraction. So you can see is it a good crystallinity, and you can understand some epitaxial relations through this. Afterwards, chemical composition of the structure of the samples was studied with X-ray photoelectron spectroscopy. Here you can see a small scheme where the X-ray light goes on the surface of the substrate, and emitted electrons studied with electron analyzer, and due to these spectra which we received, you can understand what materials, for example, here is cuprum, and each material have got a unique spectra, and if cuprum, for example, oxidized, the spectra will change because of bonding and changing of electron levels. Through our activity was prepared quite big amount of structures, but here is presented simplest one, lanthanum fluoride on silicon 111. Also was prepared different mixtures with, for example, strontium fluoride, which shows preliminary results of increasing of ionic conductions in this film for up to 2 orders. And to understand the structure of lanthanum fluoride film on silicon, sputtering was used to obtain spectra not only on the surface but also in the middle and in the interface of the film. Here presented X-ray photoelectron spectra on the surface, green one, which is in a good correspondence with lanthanum fluoride. A middle and interface, you can see an increasement of the right shoulder which points on the oxidation of the film. Oxygen spectra also proves this graphs, also proves this hypothesis. You can see a quite big increasement of oxygen through all over the film. Moreover, it was made a quantitative analysis of lanthanum fluoride film to understand the chemical composition, not only on the surface, through all over the film. And on the surface, as we can see, we've got more or less clean lanthanum fluoride. But if we go deeper, in the middle, already in the middle of the film, we see quite high oxidation, which points us on lanthanum oxafluoride, which has different structure and different conductive parameters. Here is a list of my publication and these activities for this year. Thanks, everybody. If you've got any questions, you're welcome.
Questions? You have already 2 accepted papers on journals?
Yes, but it's a little bit on different activities, which was connected to arrays of magnetic nanoparticles. And we've got a collaboration with a laboratory in Russia, and I was going on synchrotron to study these phenomena with our colleagues. Okay. And it's related to it.
Congratulations for that.
Thank you.
The next candidate is Mr. Francesco Maria Puglisi. And then we will have the last talk.